We don't have to wait for the Spring AI project to be released. We can use basic capabilities of Spring and Spring Boot to talk to ChatGPT right now. Welcome to Tales from the Jar Side. In our previous video, we used the Spring capabilities in Spring 6 and Spring Boot 3 to talk directly to OpenAI's API and list the available models. But this time, we're going to add to that project and wind up talking to Chat. Now, what I have open here is platform.openai.com, the website that has the documentation for the chat part of OpenAI. And you see there's a chat completion object for the results, and then there's a chat request also that we'll have to transmit. It's a little hard to see here, so let me show this to you slightly differently. The documentation basically says that we have an endpoint. This time the endpoint is at version 1/chat/completions this time instead of models. We do need to submit a post request to that, and in that post request we're going to have to put in our chat request object. But we can use the same parsing, the same web client, everything we used before we could reuse now. In this particular case, we do have to worry about the pricing. When all you do is find out what models are available or find out your own spending, that doesn't cost anything. But there is a cost to accessing the GPT models. The cost, however, is very, very low. All prices that are quoted in the documentation are per 1,000 tokens, and 1,000 token is about 750 words. And there's an actual pricing document if you'd like to take a look at it. But let me just show you as a summary here. With GPT-4, the latest and greatest, then 1,000 input tokens costs about 3 cents, and 1,000 output tokens costs about 6 cents. Now, input tokens do tend to accumulate because if you do this thing they call prompt engineering these days, then it gets a little bit longer, you know, what you're going to send in. But 1,000 tokens is 750 words. That's a lot. Now, in GPT-3, you'll notice that the prices have been cut by about a factor of 20. Instead of 3 cents, it's 0.0015 cents, or instead of 6 cents, it's 0.002 tenths of a cent, if you will, per 1,000 tokens. And we're going to get back a usage block from our response that tells us how much we used. So this isn't going to be terribly expensive, fortunately. Now, getting back to the JSON data, over here on the right is their sample from that documentation of what the request is supposed to look like. Now, this is not showing all the optional parameters, but it is showing the required ones. So we need to submit a model. We need to pick which model we're using, and there's GPT-4 and GPT 3.5 Turbo, etc. Messages is an array, a collection of individual message objects. Each message is a combination of role and content. Role takes the form of either system, if you're not asking a question, if you're just trying to set up the question, or user, which is what you use when you're submitting a question, or assistant, which is what will be in the response, or even function if you want to do a function call. We're not going to do that now. Another property that gets added to this normally is temperature, which is a floating point value to specify the degree of randomness you want out of this. Now, this is easy enough to convert to Java records. That's the nice thing about it. So here's a couple of Java records that map to that structure. The chat request will take a string model, a list of message, and that double temperature I was mentioning. And then the message record will simply have a role and a content. Now, what I'm showing on the slide here is something I'm not going to do right now, but is in the GitHub repository. And that is I turned role from a string into an actual enum so I could control the possible values that go in and come back out of it. The only problem with doing that is that then I have to do additional configuration on my JSON parser to make sure that the actual role comes out in lowercase. So I'm going to hold off on that, but if you want to see the details, they're all in the GitHub repository. Now let's look at the response. The response looks much more complicated, but a lot of this we don't care about, and some of it's very, very simple. So if we look at the JSON structure on the right here, the ID is just some random string that isn't affecting what we get back. And object is always chat.completion. So again, don't really care. The created value is a Unix timestamp again. Yeah, okay, that's nice. The model will tell us which model we actually wound up using. We can ask for GPT 3.5 Turbo and it'll say, oh yeah, we picked the June 13th version of it, which is fine. Then we have a block called choices and we have a block called usage. Looking at the usage one first, the usage block is our list of tokens. How many prompt tokens, how many completion tokens, and then add them up together to get the total. The choices block is a list, which is kind of silly because there's only ever one element in that list. It has an index of 0, not surprising, and then it reuses that message structure to say, oh yeah, this is a response from the assistant role and here's our content. They also throw in a finish reason, so you can optionally, if you like, check to make sure the finish reason is in fact stop so that it worked properly. Okay, given that structure, here is a collection of records that I put together that maps to it. So you can see here the chat response record has the ID, the object, the created timestamp, the model as a string in this case, usage as a chat usage object, which is right below, and then choices is a list of chat response choice, which is below that. The chat usage is just a wrapper for those 3 integers for the tokens, and the chat response choice has the message in it, which has got the content that we want, and the index, which will be 0, and the finish reason in case we want it. Notice how we are using camel case in many places in Java, whereas the JSON data is all based on snake case, so we do have to make sure that happens. So that is our collection of records, and now it's time to go to the code and see how we implement all this. Let me just summarize what we have in our existing app to give you an idea of what we're looking at. This is an example of Spring Boot 3's HTTP Exchange interfaces. I say Spring Boot 3, but it's really Spring 6, but it's bundled inside of Spring Boot 3. This is a REST client that allows you to customize a client for an endpoint without having to write all the code associated with the web client class that's going to access the endpoint and get back a response. In the previous video on this series, which I'll link to, we put in a list models method that returns a model list, and a model list was this simple record that had a list of model in it. The model itself combined an ID, a created, and an owned by, and here is our JSON naming annotation used in order to make the Jackson JSON parser understand how to convert from camel case to snake case and back. Now this all required us to set up a bean. Now I have a configuration file here, a Java config file, annotated with that configuration to tell Spring, yes, this is setting up some beans for you. I customized the web client by injecting in the base URL. The value of this base URL is in our application.properties file, and the value of OpenAI API key is an environment variable. All I have to do is use this syntax, and it will be injected into this method. So I used a builder. I set the authorization header to say bearer and the formatted value of that API key, and set the base URL and built it. So that took care of making sure that our authorization header is inside every request we send. And then this method here, this bean, is all about the boilerplate. This boilerplate is taken almost exactly from the documentation for HTTP interfaces. So it's all about customizing an HTTP service proxy factory to work with that client bean up here, that web client we're talking about. It does have I did set a long timeout for it, but that's partly because it takes a little while to respond to the chat sometimes. That's going to become more important when we talk about image generation. But all of this is boilerplate. The only thing that changes each time is which interface I'm submitting, maybe how long I want to wait for it, and then the return type, and that's it. Now it's time to make the additions that will involve the ChatGPT part. So the first thing I'm going to do is go to my JSON package and add in all of those records. Okay, let's take a look at the records. Here's the chat request. The chat request takes the string model, a list of message, and a double temperature. Here's the message. The message has a string role and the string content. So that's going to be used both for the question we ask and for the response that comes back from GPT. The response looks like this. Again, I've got the JSON property naming strategies and all that in here. The idea is that this is going to have an ID, an object, a created, the model, the usage, and choices, the list of choice. And inside here, I just nested the usage and the choice. The idea of dealing with the property naming strategies and the JSON naming annotation I already mentioned. Here I've applied it to the individual records. If I was using POJOs, I could set one property and application.properties and everything would convert automatically, but I like using records, so I'm going to stick with this and put it on each one that needs it. So there's my JSON data going in and my JSON response coming out, all converted to records. Now let's go and take a look at the interface. The nice thing about using the HTTP Exchange interfaces is I don't need to modify that web client at all. Those beans that are ready to go are still ready to go. All I have to do is add a method to our HTTP interface. In this case, I'm doing a post exchange where I'm going to the chat/completions endpoint. So it's a slightly different endpoint, but it's still based on v1 here and on our base URL. Now I did go ahead and set the accept header and the content type header so that I'm passing JSON data and receiving JSON data, but this service would have worked that way even if I hadn't set it. It just seems like a good practice. So the method I have added takes a chat request from the request body, because I am doing a post here, and returns a chat response. Now this introduces a little bit of a complication, not too much, but the problem now is if I want to access this, I have to create a chat request, and what I'm going to get back is the chat response, and I've got to parse that thing. Now we'll do that, but then I'll show some opportunities to simplify this. So what I'm going to do now is I'm going to add a test case and go ahead and exercise this, and we'll see that. What I have here now is the same Spring Boot test that I used in the last video, the one that was operating on that OpenAI interface, if you will. I've added a logger here based on SLF4J, because that's already included in Spring, so that I could see the outputs. What I've done this time is I have created a request simply by instantiating the chat request record. I specified the model as GPT 3.5-Turbo. I had to make a list of messages, and I've just put in a user message, and this is the example they use on their website. Say this is a test, and I picked a temperature of 0.7. Probably should have picked something closer to 0. That makes it more deterministic. Something closer to 1 is going to be a bit more random. But if I tell it to say this is a test, I'm going to get something back that says this is a test. Here I invoke the method, the one that we put in with the endpoint and everything to get the chat response. Now I can log the usage and see exactly what that looks like. And then see, this is the part that's a little bit painful. I have to walk down the records in order to get the content. And this is something where the Python people are going, you know, we could do it so much more easily than this. And there's a point here. From the response, I get to the choices. That's the chat response choice object, the inner one. And then get the first one. That'll be the only value inside the collection, and then getting the message will return a message, and then getting the content will give me the content, and there's my string. And I'll log it and I'll check that it is in fact equal to this is a test. So when I execute this one, what you see here is we did in fact execute a post request to the proper endpoint. We got back a 200 response, and here's the logging of the usage. So you see it was only 18 total tokens, no matter how you divide it. And there's the response. It's exactly what we wanted. So it was easy enough to get there, and we wound up getting there, and it looks all very good. Let me just make one simplification here, and it's the extraction of that method. Now, I could go ahead and make a whole service, and I'm going to do that in a moment, and go ahead and inject the interface into the service. But you know, Java, since Java 8, has had default methods and interfaces. And the method of extracting the value here from the response is directly related to the response. So what the heck? Let's see what that looks like. What I have now added to our OpenAI interface is a default method. So it's a method with a body that's implemented right in the interface. And fortunately, this does not interfere in any way with the generation of the web client code that we need to make the access. I'll just say if I send in a chat response, then you walk the tree and return the resulting string. So let's see how well that works. So the only change I made here to the test is that now when I get the response back, I'm just going to call that extract string response method. And that way I'll get the content right out of it. Let me run it again, make sure I didn't break anything. And you can see everything is identical. It all worked just fine. So it's okay to go ahead and add default methods to interfaces, even an interface that's going to be used by Spring to automatically generate this web client code that we're using to make the connection. I could also add in a method to generate the request as well. And in the GitHub repository associated with this, I do in fact have that. But then it becomes a question, how much of this do I want in the interface, and why wouldn't I want to use a class at some point? So what I'm going to do now is I'm going to add an actual service class, and then I'll talk about why, what's that for. So let me go ahead and take care of that. What I've added to our system now is an OpenAI service. This is annotated with the @service annotation, so it is picked up on a component scan inside of Spring. What I've also done is used constructor auto wiring to auto wire in our service. And what I also threw in here, and this is the questionable, debatable, this is the thing you might want to think about, is I made an attribute of type model list that is going to hold the names of all of the individual models. And what I'm doing is I'm going to invoke a method to get all those model names, and I'm going to save it as an attribute. Now, the reason I'm doing this, of course, is I got burned. I wound up sending in a request for a model where I left out a dash. I put in GPT-4, I forgot it was GPT-4, and I kept getting errors. And I couldn't figure out from the responses what the error was. And when I clicked on links, they were failing. It just, everything was wrong. So I'm getting a little defensive here and saying, well, you know what, when I create this service, and Spring's going to manage it as a singleton anyway, so what the heck, let's do this once, get all the model names, and that way when I make a request, I can check and make sure that that model name is inside that list. It's contained inside there, and otherwise I'll throw an exception. Now this is partly why I'm going to a class here. See, the class is in the same services package with the interface. The one thing you can't do in an interface is have state variables. You can't have attributes that aren't constants. And in this case, I would like to have an attribute that is a list of those model names. Now, there may be other attributes to come as well, like I've got the logger set up and everything. But what you can't do in an interface is put in instance variables. That's what I'm doing here. And among other reasons, I could also make this transactional and so on. It's nice to have a service class available. Now, my method to get the model names is going to delegate to that OpenAI interface to list the models, and then I will get the data out of it, turn it into a stream, map them to their IDs, convert it to a list, and that winds up setting up the names. Now, I did decide to make that public because there's no reason the outside world couldn't get the model names if that's what they wanted. Figured seemed okay. But this is the method where all the work is going to happen. I will provide a model and a list of message and a temperature, and here's where I check. If the model names does not contain model, throw an illegal argument exception with the error invalid model name. Then I'll actually instantiate the request. I'll get the response back as a response. I'll print out the usage. And this time it looks like I forgot to put in the, let me update this to OpenAI interface.extract string response from the response. There we go. So now it's taking advantage of our default method in the interface as well. What I need now is a test. Okay, so here's my test. I made it a typical Spring Boot test. I'm auto-wiring in the OpenAI service this time. To test the get model names, I'll go ahead and invoke it and get back the list and assert that there's a GPT in there somewhere. I mean, it's not much of a requirement, but it's something. And in fact, I'll print them out. I'll print out the ones that say GPT on them, just so I could see it. On the test for the response here, I'm going to use GPT-4 this time. What the heck? Why not? And my list of message this time will be a message of type user and say, according to Douglas Adams, what is the ultimate answer to the ultimate question of life, the universe, and everything? I'll put in a low temperature on this one. I'll print the response and check that it contains the number 42. So let me do these one at a time. Let me run the get model names test first, and we'll be able to see the model names that have GPT in it. So you can see the test did in fact pass, and here are the GPT-based models. They're not in any particular order. I could have sorted them. In fact, see, that's the nice thing about having Java now. I could actually go .sorted and then run this again, and now they'll be in alphabetical order. And isn't that convenient? So you can see them right there. There's the 3.5 models. There's the 4 models. Now, what about the response here? Let me try invoking that. And what we see once again is that there's a post request to the completions endpoint. It tells me that it's encoding this request and message object and everything into the request. We transmit it, we get back a 200 OK, then it's decoding it. I mean, look at that ID. I don't care about that ID and the object here and the created. No. All I want is the answer, and the answer, the ultimate answer to the ultimate question of life, the universe, and everything, as you probably know, is 42. There are other refinements we could do to this. There's plenty of things I could add. As I say, I could go to an actual role enum as long as I customize the setting. In the GitHub repository, I made the most common models into constants so I could access GPT-3.5 and GPT-4 from constant names that already sets it properly. That way I can't get it wrong. That's the idea. I also put in a simpler method to create a request if there's only one message. In this case, there's the possibility of many messages, but if I only have one, I could put that in. And of course, I could do much more sophisticated calls, which have multiple messages, both system messages in them and user messages in them. And I may get to that in another video. But this was kind of all you needed in order to tie GPT capabilities into your existing Java Spring app. I hope you enjoyed this. For other videos, please be sure to subscribe so you see everything from Tales from the Jar side. Thank you very much.
Tech dose that never ends.